course of a class and making sure everyone's taking the correct notes and everything and not just hanging out. Right? Because if we haven't got it yet, we need a little wake-up call, a few of us. All right, here we go, right off the bat. The name of this unit, relationships and triangles. We're still dealing with triangles. All right, still dealing with triangles. Please do me a favor, put the darn compass off to the side. It's going to be a distraction until you need it. All right, we're not going to need it to the very end of today's notes. All right, take your colored pencil first. Box it in, circle it, highlight it, whatever you're going to do. The first word here, concurrent lines. Anytime I have you box it in, circle it, highlight it, that means it's a vocabulary term you are unfamiliar with, and somehow you got to get familiar with it. Index cards, Quizlet, whatever your go-to is. Whatever your go-to is. All right, because this unit is going to, some of you are going to struggle because it's got a lot of vocab in it. A lot of vocab. So I'm going to do my best to say, hey, remind yourself this is a vocabulary term we need to know. So the first one, concurrent lines. In the first box right now, draw. I don't need a compass or a straight edge. Just draw me 3 lines that all intersect each other at a single point. All right. 3 lines. I don't care what angle they come in, that all intersect at the same point. Those 3 lines you just drew are called concurrent. They're concurrent lines because there's 3 of them and they all intersect at the same point. All right. If I have 2 lines that intersect, they're not. That's got to be 3 or more, everybody. 3 or more that intersect at the same point. That's called concurrent lines. All right, so I want to start using that word now in here, concurrent. If you see 3 lines or more that intersect at the same point, you call them concurrent, not 3 lines that intersect. All right, mark that point where they all intersect. And that's the last time I call it that point. Again, grab a colored pencil, whatever you got. Second vocabulary term, and we're only 2 minutes into class. That point where they intersect, we're going to start referring to now as the point of concurrency. Pretty clever, huh? Concurrent lines have a point of concurrency. So we all good so far in our new vocab. Concurrent lines, 3 or more lines that intersect at the same point, and that point's called the point of concurrency. All right, second box. Can you please draw a triangle in for me? All right, nothing huge, just to draw a standard triangle in there. And now we're going to take a circle and draw it around the triangle, but here is the requirement. The circle must touch all 3 vertices when you draw it around. So you want to wait for me or try it on your own. The circle must touch all 3 vertices of the triangle on the outside. All right, just like that. Yeah, grab your colored pencil. Number 3 already. Circumscribed. That circle, this circle that you just drew around the triangle is called a circumscribed circle. Why don't I call it the triangle circumscribed? Here's why. Any figure that's circumscribed is always drawn on the outside of another figure. So that's why I'm saying circle and not triangle here. Everyone see the circle is the one drawn on the outside. All right, so anytime it's on the outside, I call it circumscribed. Reverse it for me now in the third and final box. Reverse it for me. Draw a triangle again. Draw a triangle. But now I want the circle on the inside. But the circle must touch each side of the triangle in one spot only. All right, so when you draw that circle inside, it's got to hit each side of the triangle in one and only one spot. And, yep, Colored pencil out again. Let's circle, highlight that word inscribed. So now we're going to say the circle is an inscribed circle. Anytime a figure is on the inside, it's on the inside. We call it an inscribed figure. All right, speaking of the numbers, let's do them right now. Go back to my second diagram. What can you tell me about the triangle now? Now that we have all these vocabulary words. That triangle is what? We know the circle's circumscribed because it's on the outside. What could you tell me about the triangle? The triangle is, using one of these vocabulary terms, what can I say about that triangle? Drew? It's an inscribed triangle. Good. And what can I say about the triangle here? It's third box, 16. Bryson, what can I say about the triangle here? The circle's inscribed, but the triangle is circumscribed because it's on the outside. Everybody good? Questions? Okay. So 1, 2, 3, 4 vocabulary terms already, and it's only 8:37. All right. Index cards, Quizlet, whatever you have to do to keep track, because I'm not even done with the vocabulary terms today. All right, you can turn to the next page. I'm just going to show you what our focus is going to be on today. Is this right here. A vocabulary term we've talked about in the last couple units. I just want to go over it before we apply it to your notes. Perpendicular bisector. So see if you can answer a couple questions for me. I have triangle ABC up here. I'll call that D and E. All right, so I'm going to say DE is your perpendicular bisector here for this side AC. Now I'm going to ask you guys, what markings can I put on here then? What markings can I put on? All right, if you know DE is the perpendicular bisector of side AC, what I want to know first, before we even go back to the notes, what markings can I put on my diagram? All right, if this is a perpendicular bisector for AC, what markings can you put on? What's perpendicular? What's bisector mean again? Before we start our notes here. Stephanie, one markings I can put on here? Yep. These are right angles. All right, these are right angles. Why are they right angles? Perpendicular. Forms right angles. All right, somebody take care of this. What markings can I put on AC now if this line bisects it? Bisects it. Here we go. 2, Bailey. DE is bisecting side AC.
Then AE and EC are congruent.
Yep. What markings do I put on there to show that?
The attachment.
You got it. Okay. So that's what we're going to focus on today. All right. We're going to right now have a triangle graphed, and we're going to do the perpendicular bisector for all 3 sides and see what happens. Okay. All 3 sides, not one, all 3. So first thing I need you guys to do, go ahead and graph triangle ABC for me. All right, go ahead. Let's go. Graph. We're on the next page now. Please use a straight edge to connect the vertices and label the vertices with their letters, please. Label the vertices with their letters. 1, 2, 3, 4, 5 groups. Okay. Okay, just make sure those A, B, and C are on those vertices for me. All right, everyone's going to be assigned a group right now. Okay, everyone's going to be assigned a group number, and you'll have one task each time here. Because what we're going to do, here's our goal at the end. I want the perpendicular bisector through AC, through BC, and through AB. So at the end of this, on our graph, we should have 3 lines that are the perpendicular bisector for the 3 sides, and then we're going to see something about it. All right, so here's our groups here. Group 1 is this full row right here, group 1. Okay, group 2, or it's going to be these 2 right here, and you guys are group 3 by yourselves. So all I want you to do first, and we just finished the cumulative quiz yesterday where you needed to know the formula. Group 1, you're going to find the midpoint of AC only. That's your one job. All right. Group 2, you're going to find the midpoint of BC only. And then group 3, find the midpoint of AB. What are the coordinates of each? I'll give you guys about a minute and a half because that's all it should take. All right. We just went over the formula yesterday. Talk to your group about it. Make sure you're in agreement before I call on somebody. Find the midpoint of your respective side. Do not do anybody else's side. Just worry about your side only. Find the midpoint of it. Write it down. Make sure everyone in your group is in agreement too what that midpoint is. Just needed the formula yesterday on the quiz. It's a little rough if we don't know the midpoint formula, right? We just did it yesterday. Probably reflective of the grade we got. Too soon? Too soon? Too harsh? All right, group 1, we got to roll. Group 1, what'd you guys find for the midpoint of AC? Anybody? I don't care. Here we go. We got to roll.
4-1.
4-1. Good. Now, everybody, I want to call that point X, please. I want to call that point X, so please fill in your chart. That's 4, 1. And please go to the graph and graph 4-1 and call it X. All right, please go to triangle ABC, graph 4-1, and it should land where it should on AC, because it's the midpoint, and call that point X. All right, let's keep moving here. Group 2, anybody from group 2, midpoint of BC? 8-2, yep. And please call that point Y, everybody in your table. Call that point Y, graph it. Call it point Y on the graph. You'll notice it lands on BC like it should. And then finally, group 3 over there, what do we get for midpoint of AB? 5-4. Call that point Z in your chart, everybody. Point Z, 5, 4. And graph it. So you should have all 3 midpoints graphed. Why am I having you find midpoints? Because remember what our goal is. Our goal here is to do the perpendicular bisectors, and they have to go through the midpoint of each side. So that's why we're doing midpoint. Next job for you and your group. Same group numbers. Find the slopes of each side now. So if you need a little refresh, you can do rise over run, or you can do change in Y over change in X. So you find the slope of your side, and then talk in your group, what would be the slope of a line perpendicular to it? So you got to remember the relationship between 2 lines that are perpendicular and their slopes. That was on the quiz yesterday too. So find the slope, and then try to fill out the second column. What's the slope of a line perpendicular to it? All right, so another minute and a half. Look around with each other. Make sure you're in agreement. Just of your side only, though.
-2/3.
Let's go.
I literally just counted it out on my You're smart. I did.
Lowest terms too, please. Yes, Stephanie. Sure. Lowest terms. So reduce it, please. Reduce it if you can. All right, let's do this. Group 1, what was the slope of AC? What did you have?
-2/3.
-2/3, got it. What would be a slope of a line perpendicular to it?
Would be equal
Well, parallel, they're equal. I don't want to write -2/3 again. What do I want to write here? The negative reciprocal, which would be group 1? +3/2. All right, we're going to do something with this right now, with that 3/2. You're going to go back to midpoint X. And I want another point that's got a slope with it of 3/2 so I can draw in the perpendicular bisector. So if I know the slope is 3/2, where can I go from X to find a second point using 3/2? Where am I going to go here? Tell me the directions, up, down, left, and right, and how many units. If the slope's got to be 3/2, where do I go from X? Where am I going to go from X here to get it to graph a second point? You're right. I got to do this better. Bryson, you're up. Where do I go here? From point X, the slope's got to be 3/2, and I want to do a little rise over run here. So where do you suggest I go? Okay, when you say over, that could be left or right.
Right.
Right 2. So everyone ready? Up 3, 1, 2, 3, to the right 2, and graph a second point. And then I want you to grab your straight edge and a colored pencil and draw in your first perpendicular bisector. Got to be a straight edge for this to work. That line is the perpendicular bisector for side AC. Cuts it in half and it forms a right angle. We're going to do that 2 more times for the other 2 sides. So let me go to group 2 now. What'd you guys find the slope of BC? Group 2? 3/1, yep. So my perpendicular line is going to have a slope of what, though? Just +1/3? Right? Now I got to change the sign. -1/3. Everyone ready? Go to point Y. How can I graph another point from point Y now? I'm going to somebody else. So -1/3 is my slope. Where do you want me to go to graph a second point from Y now? Let's roll 2. Bailey, where do you want me to go to graph a second point?
Down 1 or right 3.
Good. Everyone go down 1 to the right. 1, 2, 3. Grab your straight edge and a second colored pencil and graph in your second perpendicular bisector. That's what we're graphing here. Perpendicular bisectors for each side. And we're going to do it one more time. Group 3. What was your slope of AB? 1/4. Yep. So when I'm about to do this perpendicular bisector, what's going to be its slope? -4/1. Good work. So make sure everyone fills out their chart. And now go to point Z. Let's go to our final point. Point Z. How can I find another point from point Z now? Where do you want me to go? Ooh. All right, here we go. Bryson, back up. Where do you want me to go? Slope's -4/1.
Down 4 and to the right 1.
There you go. Down 4, right 1, everybody. And you're going to have to share now, borrow from each other. Grab a third color and graph your third perpendicular bisector. And take a look at all three now. Look at your graph, take a look at all three. Anything you want to tell me about all three right now? And I want you to use vocabulary terms from today, please. Okay? I want you to use a vocabulary term from today. What do I notice about all three perpendicular bisectors? All three perpendicular bisectors. Here we go. Tell me what you see there. 5. Jared, what do you see? They're concurrent. All right, and that will happen every time. I don't care what the triangle looks like. If you do all three perpendicular bisectors, they will be concurrent. So let's answer the questions down here. Are these lines concurrent? You're darn right. Yes? And our conclusion. All three. What did we just graph here? What are all three of these lines called? Again, one more time. What are all three called? Stellan? There you go. All three perpendicular bisectors in a triangle are, and what's the term we're using for this now, where they all intersect at the same point? All three perpendicular bisectors are, Brendan? Concurrent. There you go. You can just take your pen, pencil, whatever you're working with. Mark that point where they're all concurrent at. What word did I give you for that point again? Where they're all concurrent. What did I give you for that point again? Cormac, what's that point called? Where all three of those intersect? Okay, point of concurrency. But now, when it's the perpendicular bisectors that meet, I don't want to say point of concurrency. I'm going to give it a special name now, specifically for the perpendicular bisectors. That point now we're going to refer to as the circumcenter. That is reserved for perpendicular bisectors only, the circumcenter. So is it a point of concurrency? Yes, but because it's formed by the perpendicular bisectors, we give it a special name called the circumcenter. Grab your compass, please. We're about to show you the special fact about the circumcenter. Grab your compass, put your point of your compass on that circumcenter. The point of your compass should be on the circumcenter. Your pencil point, put it on point A, B, or C, the vertice. One of the three vertices, please. Don't make any markings, just open it up to a vertice. Put your pencil point on a second vertice now. Did you have to open or close it? Or did it pretty much landed right on there, didn't it? And then put it on the third vertice. What am I trying to show you guys? That circumcenter is the same distance from all three vertices. Okay, that's what you're showing yourself right now by using your compass. The circumcenter is the same distance from all three vertices of the triangle. Are we seeing that? And yes, some of you are figuring out I can make a nice little pretty circle around it as well. Yes, I can. All right, it's equal distant from all three vertices. All right, compass off to the side. You'll need it at the end of the notes here. All right, let's go to the next page. So the theorem, everyone, the theorem in the box is just what we went over. I use the word equidistant, all right? But again, perpendicular the circumcenter, equal distant away from the vertices. In the diagram I have here, triangle ABC, do me a favor. I'm going to tell you point O is the circumcenter. Okay, point O is the circumcenter. That's power. That's powerful. Grab your grab a colored pencil right now. Let's do these in dashed lines now. Dashed lines. Draw a dashed line from O to B. Draw a dashed segment from O to B. Do a dashed segment from O to A and O to C. What do you know about all three dashed line segments? O is the circumcenter, and we just showed using your compass that it's the same distance away. So what do you know about those three dashed lines? Go ahead, Lily. What do you know? They're all congruent to each other. So right down below, OA is congruent to OC, is congruent to OB. Okay? The circumcenter is the same distance from all three vertices. All right, we just spent a lot of time figuring all this out. Now we're going to use it. All right, use it with some numbers now. Let's see what we got. These three are perpendicular bisectors. Grab a colored pencil. Here we go. I know this is elementary schoolish, but it's the way I'm going to get it through to you guys. Highlight ZW, one of the perpendicular bisectors. Highlight ZW. Put markings on your diagram now. If ZW is a perpendicular bisector, there should be a couple markings you can make right now on that diagram. And I'm going to ask a few of you what markings you made. All right? Just start with ZW. I'm not ready for the other two yet. ZW, perpendicular bisector. All right, great. What markings can you put on your diagram if ZW is a perpendicular bisector? 18. Lily, go ahead. One pair only. We should have hash marks here. Great job. Lily took care of the bisector part. Somebody's got to take care of the perpendicular part. What other markings should I have on here somewhere? One. Zoli, what other markings?
TWZ is equal to VWZ.
Yep, I don't want to put arc marks because I know exactly how many degrees it'll be if it's perpendicular.
Because of right angles.
I should have right angles here. So everyone good? Grab a second color. ZY is a perpendicular bisector. Go ahead. ZY, highlight it, and mark it now. If ZY is a perpendicular bisector, mark it. And let me know what markings you're putting on your diagram now. Micaiah, give me a grouping of markings you're putting on.
Hash marks.
On?
D, Y,
Yep. And we should also be putting on what else here with this? Solely back to you. What else should I be putting on here?
VYZ is equal to UYZ because of right angles.
There we go. I got right angle symbols there. One more color. ZX is a perpendicular bisector. ZX. So make sure we highlight ZX. And tell me what markings you're putting on there. Ooh, Henry, markings.
EX and U are congruent.
Actually, I should probably put 2 there. There we go. And other markings on there. One more pair of markings that should go on there. Ooh, 2, Bailey, another pair of markings.
right angles.
Yep.
ZXT and ZXT.
Got it. Look at all those markings. Just because we know those, and we're not done with the markings either. Tell me something about point Z. These are three perpendicular bisectors that just met at Z. Tell me something about point Z. Anything about point Z you want to tell me? These are three perpendicular bisectors that just met there. What do we know about point Z? Ooh, HR, where is it? Okay, we got a special name for it though, right? I agree with you, but we have an even better name because these are perpendicular bisectors. This is the circumcenter. Point B is the circumcenter. Everyone all right on how we got there? All right, so that means if Z is the circumcenter, there's three more segments up there that should be congruent to each other. Because I know a fact about the circumcenter. It is blank. All right, so name three other segments up here that should be congruent. If Z is the circumcenter. What are my three other segments? Whew, asking a lot here. Brendan, back over to you.
CX would be congruent with WZ.
Okay, it's not equal distant from the sides. It's equal distant from the vertices. So now rename three segments that should be congruent up here. Yep. Okay, everyone, we good. Circumcenter, not equal distant from the sides. It's the same distance from the vertices. So these three are congruent to each other. Whew. Look at that diagram, just from those directions. We haven't even solved the darn thing yet. All right, now hopefully this goes quick now. TU, what's the length of TU? All right, look at everything we marked up here. TU, length of TU, and let me know how you got it as well. Length of TU. Yep, crunch some numbers real quick. 4 tests, length of TU. 38. If anybody's wondering how she got it, she doubled 19. Okay, and again, I don't know the other side's 19 unless I know what a perpendicular bisector is. Good job. VY. All right, let's keep rolling. VY, 17. Dylan? 17. Yep. Cut 34 in half, everyone, right? Cut 34 in half. UZ. UZ. Again, I can't find what UZ is unless I know what the circumcenter does. UZ. Micaiah, UZ. 21. Right? Same distance as the other two vertices are. All right, now we got to do a little teaching here. WV. Everyone look at WV. Usually I'd say it's cut VT in half, right? But I don't know VT. So there's no way I'm going to find VW. So here's how we're going to do it. Everyone take a look at triangle ZWV, please. ZWV. Look at that triangle. You don't have to highlight it. I'll do it up here. ZWV. What type of triangle is it? It's a right triangle. How many sides do we know the length of? Look at it. How many sides do we know the length of? 2 or 1? 2. Anybody know in a right triangle, if I know 2 sides, I can find the third by using Pythagorean theorem. Okay, Pythagorean theorem. If you know 2 sides of a right triangle, you can find the third by using Pythagorean theorem. For A and B, is this familiar or no? Not at all. Not from last year at all. Didn't even sniff it last year, huh? You get it. Come on. I got some of you saying yes, some of you saying no. Nothing at all. All right, I'm going to figure this out once for all and go next door and ask Mr. Shai if he did it or not.
Yeah, I don't know.
We definitely did it.
We eat at the end of the year, but I just didn't want to look stupid. So I said
Oh my god, look how big it is. So tiny.
What do you say?
So I guess the answers depend on who you had last year. Real good. All right. All right, so if you have a right triangle, I'll back up. If you have a right triangle and you know two sides, all right, the sides that make up the right angle, called the legs, that's your A and B. And the C, and remember what this was called? We definitely talked about this last unit. That's my hypotenuse. That's your C value. Okay? And you can only use it, though, if you know two sides. All right? Can only be used if I know two sides. So what's one side that makes up the right angle here? Oh, 21 looks like this side here. What's one side that makes up the right angle that I know? 15, right? So I plug that in for A. 15 squared. And I'll go through this slowly because you're going to need this tonight on the homework. Plus, the other side that makes up the right angle is the side I'm looking for. Everyone agree? So you can call that X. You can leave it a B if you want. Equals, what's the hypotenuse in that triangle? 21 equals 21 squared. All right, so 15 squared, and everyone's got calculators. Let's do this. 15 squared. 225 plus B squared equals 21 squared. 441. Okay, we're getting there. You tell me what to do next. Remember, I'm trying to get B by itself. So how do I get rid of that 225? Subtract it over. Go ahead, everyone. Subtract it over. B squared equals 216. Yeah. But that's B squared. I need B by itself, though. So all right, we did learn that in algebra last year. We're good, no matter who you had. To get rid of a squared, we take the square root. Now just take a peek at the directions. It does say leave your answers in simplest radical form. Your calculator gives you that in a decimal answer. I want the simplest radical form answer, please. Which should be 6 radical 6. There you go. 6 radical 6. So if I know two sides of a right triangle, you can use this theorem, Pythag, to find the third side. I have one more question for you, and that's what's the length of TV now? TV. Well, we just found WV was 6 radical 6. What's TW then? Also 6 radical 6. What do I need to do to the two to find the full side? Add them together. I don't care if you did radicals or not last year. You can type it into your calculator. And you end up with TV, simplest radical form in your calculator there, 17. Finish this up, Dylan. 12 radical 6. Good. Okay, because of time constraints, I'm going to skip over that last problem on the constructions, and I want you to start right on the assignment right now. All right, doing problems just like we did here. Mark up your diagram first. Mark up your diagram. Oh, this is a perpendicular bisector. This is a right angle. This is congruent. Oh, that's a circumcenter. Everything to the vertices are equal.